Good morning, good afternoon, good evening, ladies and gentlemen, and in today's video we're going to be looking at sine law. Okay, so beforehand we'd always be working with right angle triangles. So it always had a 90-degree triangle in one of it, a 90-degree angle, and we were able to use SOHCAHTOA because of that, and Pythagorean theorem. So the question is then, what happens when you don't have a right angle triangle? So here you see a normal triangle that does not have a 90-degree angle. In this case, you can't use SOHCAHTOA. In fact, you can't even use Pythagorean theorem because this is not a 90-degree triangle. So that brings us to what is called as sine law. So sine law states that if you have this nice triangle here, use a lightsaber for this one, but see for this triangle here where basically the lowercase letters of the sides are the sides, the uppercase are the angles. So sine law states that you can have a divided by sine A is equal to b divided by sine B, which is equal to c divided by sine C. Now, this is true in most cases. In fact, it's true pretty much in every case. So, when can I use this? Let's take a look. So when can I use sine law? So you can use sine law in two different cases. So case one, if I have, let's say my triangle again, and in this triangle I have two sides, let's say this side and this side, and an angle that belongs to one of those sides. Now you can see that this angle clearly belongs to the 49. See, this 49 belongs to the 115. This angle here would have belonged to the 16. So in the first case, you need to be able to make sure that you have side, angle, side. Okay? And of course, this angle has to belong. Okay? So two sides. Okay? Now, you need to at least have the angle belong to one of them, mainly because it helps when you're trying to solve it. So like for instance, let's say I am missing this one right here. Well then, in this case, you can say that 16 divided by sine of, I don't know what it is, I'll give a theta, is equal to 49 divided by sine of 115. Now, in this case, you're trying to solve for this theta here. So to do this, you're going to need to do cross multiplication. This needs to multiply here, this needs to multiply here, and you'll end up getting 16 sine 115 is equal to 49 sine theta. We want to get the theta by itself, so again, you're going to divide both sides by 49 here. So you're going to get 16 sine 115 divided by 49 is equal to sine theta. And remember, whenever you're trying to solve for an angle, you're using the inverse in your calculator, so sine minus 1 of this whole mess. All right. So, obviously, this would not have been possible. You put this in your calculator, you'll get the answer you need. But this wouldn't have been possible if, let's say, I was missing the angle for this one too. I wouldn't have been able to solve it. You need to make sure that you only have one unknown, and that would be this theta over here. Okay? So like I said, first case is when you have two sides. and a angle that's included. So side, angle, side. Let's see the second case. Now, in the second case, you're going to end up having here, let's see. So let's say you have only one side now, but you have two angles. Let's call this 29. Let's call this 118. Yeah, let's go 118. Okay. So once again, you see that you still have one side and an angle that belongs to each other. So in this case, you can say sine, you can say 11 divided by sine of 29 is equal to, I have no idea what this is, let's call it b. b divided by sine of 118. Okay, so you want to get b by itself. Now you could cross multiply, or in this case, since it's already in my numerator, I can just multiply both sides by sine of 118. And voila, you're going to have 11 times sine 118 over sine 29 is equal to b. You see a difference in approach here. Now, before I did sine inverse, and I was trying to search for this, but you don't need to do inverse when you're finding the side length. So when you find the side length, it's simply like that. You don't have to do the inverse button. You type it in your calculator, and you're good to go. So the second rule states that you have to have two angles and a side. So technically, it should be two angles and a non-included side. So these two angles, one of these things have to have something missing. So you can see here, I am missing a side. And that's why I'm able to use sine law. But the side that you do have has to have the angle as well. Okay? Now I'm showing you why and when you can use sine law. And that's mainly because there are cases where you can't use sine law. So when can I not use sine law? So assume you have this triangle here. Let's draw this triangle. Let's draw Pikachu yellow here. And let's say I have two sides. And I told you before, if you have two sides, you're great. But then I put the angle here. Well, the problem is this angle belongs to this side. And I don't have this side. So let's say I'm trying to solve for this side. Let's give it the letter, let's go with C. So I have here C divided by sine of 115. Good so far, good so far. Is equal to, let's use either one of the sides, 15, 16, whatever your lucky number is. Hey, you know me, lucky number 16. 16 so was great. It's a good year. Bad birthday. So you have 16 divided by sine of, here's a problem. I don't know what this is. I'm going to call it theta. So here is the problem. The problem is, in this case, I now have two variables I don't know how to solve for. And there's absolutely no way to solve it from here. So, in this case, you cannot use sine law. Okay, so remember, you at least need to have one pairing that works, where the angle pairs up with the side. Okay? So, let's take a look at some examples of how we use this. Okay? Not ready to pretty much show you how you use it, but let's see it properly here. Okay, so let's take a look at this example. We'll call this example 1. Now, if you've already been following the steps from before, please, by all means, you can try to do this example yourself, pause it, try to do it yourself. So I didn't formally write the steps beforehand, but I will here. So step 1, set up a sine ratio with one missing variable. Okay, so you only need to set up with one missing variable, because if you have two missing variables, well, you're out of luck, as you saw in that last example. So I can see here this 105 belongs to the C. I am missing the C. So I can solve it. But can I? Let's see if we set up our ratio. So I'm going to do C divided by sine of 105, okay, is equal to, what do I make it equal to? Well, I need to find a pairing that works. So I don't have the angle for A. I can find it because, you know, every angle of a triangle when you add them together should give you 180. So I can actually find my third angle here by doing 180 minus 105 minus 35. Which would give me, well, 75 minus, that's 40 degrees. Okay. Now, I could find my third angle, as you saw there. But is it helpful? It's absolutely not helpful. Why is it not helpful? Because the side across from it, I don't have it. So I can't use this side. So that leaves me with the 7. I have the 7, and the angle associated with it is the 35. So this pairing works. So because of that, I can make the pairing. I can go 7 over sine of 35. Now, these are not special triangles. They're not special angles. They're not right angle triangles. So there's only really the quick and dirty way to do this, which is your second step. You're trying to solve for C. So in this case, when you're trying to solve for a side, all you need to do is multiply both sides by the denominator. Of the unknown. Okay, so in this case, that would be this. So I need to multiply both sides by sine of 105. Okay, so you're going to have 7 times sine of 105 divided by sine of 35. And let's go to our calculator here, and this is where you'd have to put it in and calculate it. Now, if I were to suggest the best way to do it, I would do your top first. I would actually type 7 times sine of 105 in your calculator, and when you get your answer, divided by sine of 35. Which should give you approximately, because we're going to round here to, let's go 1 decimal place, 11.8. Now, of course, this is a side, so it's not an angle or anything like that, so you don't put degrees. And assume the problem told you this was 7 meters. Then your final answer would be in meters. Okay, so don't forget your units. Okay, so that's how you find a side. Let's look at an example when you're looking for an angle. All right, so let's go with example 2 here. So in example 2, I am missing those two angles, the A and the B. Okay, now unlike the other example, I can't just add all 3 of my angles together and subtract it from 180. That's because I only have one angle. If I had 2 angles, I can find the third one easily. So what do you do in this case? Well, you're going to use, voila, sine vol. Now, the first step is going to be the same in this case when you're finding the angle. The first step is still going to be create your sine ratio. So create your sine ratio. Still going to be the first step. So to do that, once again, take one of your unknowns. Let's say I'm missing the B and the A, so let's go with the B. Let's go with that. So with B, what would belong to it? Well, 4.7 belongs to it. Divided by sine of B, I don't know what you are, is equal to. Now I need something that is fully legitimate that belongs to each other, soulmates. The 63 degrees belongs with this 5.5, so I can get that set up. Okay. All right. Now, here's where we diverge from the first type of example. When you're looking for an angle, your second step here is to cross multiply. Okay, so you're going to cross multiply here. So you're going to get 4.7 times sine of 63 is equal to 5.5 times sine of b. Third step, you're going to divide both sides. By the coefficient. Coefficient being this one. So you're going to have here 4.7 sine of 63 divided by 5.5 is equal to sine b. And then finally, take the sine inverse. Okay, so b should be sine inverse of this thing, basically. So therefore, b is equal to, so you're going to put this in your calculator, and if I were to just steps here, is basically you want to do your top again, 4.7 times sine of 63 divided by 5.5, and then do the sine inverse of your answer. This will help you get the best possible steps you can here. And let's go with, we'll round this again, so it's going to be about 49.6. But now, this is an angle, so make sure you put degrees. Okay? And that is the best you can do. That's all you can do. And that is how you use sine law. I hope this has been informative, and have yourself a great day.